This SOS video is about recursive sequences and the fact that every arithmetic and geometric explicit rule can be written recursively. So let's take a look. When you write an arithmetic or geometric sequence recursively, you need to state the starting term. It doesn't have to be the first term. We write the previous term, shown by a sub n minus 1, and the operation used on that previous term. In an arithmetic sequence, we're talking about adding, and in a geometric sequence, we're talking about multiplying. So let's take a look. In this sequence, we are going up by 3. Remember, you can take any term and subtract the previous one. 21 minus 18 is 3. 18 minus 15 is 3, and so on. So for our explicit rule, we need to know the first term, which is 9, and we need to know the common difference, which is 3. So our explicit rule would be a sub n equals our first term plus our common difference times n minus 1. We can write this recursively by first stating one of the first terms. So a sub 1 is 9. And then we say to find any term, we're going to take the previous term, and what we did to each of the previous terms, we added 3. So our pattern was we added 3. That's how it would be written recursively. Okay, let's take a look at this sequence. We're definitely not subtracting or adding the same number, because here there's a big gap, here there's a smaller gap. So it's probably a geometric sequence. Let's try this. 8 divided by 16 is 1/2. 16 divided by 32 is 1/2. 32 divided by 64 is 1/2. So we know our first term is 128, and we know our common ratio is 1/2. So how do we write that as an explicit rule? A sub n equals our first term times our common ratio to the n minus 1 power. Well, how would I write it recursively? Remember, we have to write a starting term. So I can say a sub 1 is 128. And then we write the pattern that was done to the previous term. So a sub n equals, we have our previous term. So I can say times 1/2, or a lot of times we'll put the multiplier in front. When you multiply by 1/2, it's the same as dividing by 2. So we could have written the formula like this. We're taking the previous term and we're dividing it by 2. So any arithmetic or geometric sequence can be rewritten as a recursive rule. Okay, so let's take a look at this. What's happening here? I have a previous term and I'm adding 0.2. So our pattern is that we are adding 0.2. That means this is an arithmetic sequence. So if our first term is 1.8 and my pattern is I add 0.2 to the previous term, my second term is going to be my previous term and I add 0.2, so that gives me 2. My third term is going to be my previous term, and my pattern is I'm adding 0.2, so I get 2 2/10. And my next term, I take my previous term, 2.2, and I add 0.2, and that's 2.4. Okay, let's take a look at example 2. Find the next 3 terms of the following sequence. So we're told the first term is 1/6, and to find any term, we're going to take our previous term and multiply it by 3. So we started off with our first term was 1/6. Our second term, we are going to multiply our previous term by 3. So 3 times 1/6, which is 3/6 or 1/2. Our third term is going to be multiplying our previous term by 3. Our previous term was 1/2, and 3 times 1/2 is 3/2. And finally, our fourth term, we're going to take our previous term, which is 3/2, and we're going to multiply it by 3. And we get 9/2. So if I wanted to write that as a list, this is 1/6, 1/2, 3/2, and 9/2 would be the next 3 terms of the sequence that we were given. Our last example is talking about a pattern in this truss design. A truss is a framework that supports a roof, a bridge, or another structure. So if I have one section needed, I need to have 3 beams. 1, 2, 3 beams. If I have 2 sections, I need to add 2 more of these, and I have 7 beams. 1, 2, 3, 4, 5, 6, 7. So that's 7 beams. If I'm going to have 3 sections, I need to add 2 more of these, and that is going to give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We now have 11 beams. So when we take a look at these numbers, we realize this is an arithmetic sequence. And to get to the next number, we are going to add 4 each time. So what are the different ways we can represent the following sequence as a function rule? Well, the first one would be an explicit rule for this arithmetic sequence. We need our first term and we need our common difference. And to find any term, we would have our first term plus our common difference times n minus 1. Another way to show this is in a simplified form. And a simplified form is going to look like our slope y-intercept form. And it's found by simply simplifying this. So we have a sub n equals 3 plus, and we distribute the 4n minus 4. So a sub n equals 3 minus 4 is a negative 1, 4n minus 1. Remember, we can also write this recursively. So this is our recursive rule. In our recursive rule, we need to have a starting term. So our first term was 3. And we need to show the pattern that was done on each previous term. So to get to this next term, we added 4 to the previous term. To get to 11, we added 4 to the previous term. So to find any term, we're going to take our previous term and we add 4 to it. So this SOS video has been about how we can take any arithmetic or geometric sequence and write a recursive rule for it.